Find the time it takes for $6,800 to double when invested at an annual interest rate of 20% compounded continuously. So we're talking about $6,800 and we want it to double. And then part B, we're going to do the same kind of thing. So which formula are we going to use? It's compounded continuously. So for continuous compounding, we always use A equals P e to the RT, the PERT formula. We always use that. Okay, and so we're taking $6,800. So that is the principal. That's what we're investing at the start. 20% is the interest rate. That's the R. This is the P. So 0.20. R is 0.20. And the T, well, that's what we're trying to find. We don't know T. I don't know why I did those parentheses. You don't really need parentheses. Just put a T like that. And now what's the amount? Well, we want it to double. So the amount will be 2 times $6,800. So what is it? 13,600. So we want the amount to become $13,600, don't we? That's the A. All right, so there's our equation. We need to solve that for T. How do we solve that equation for T? Let me come over here and give a good game plan here. So solving when the X or T or whatever is in power, when it's up there in the power zone. Our T or X or whatever you want to call it is up in the power zone. How do you solve for something when it's up there in the power zone like that? Well, step 1, get the base to the power, get that piece, the base to the power, alone. So this piece right here, get that piece alone. So what do I do first to get that piece alone? I'm going to have to divide by the 6,800 on both sides. And so, what does that give me? It gives me the E to the 0.20t. On the other side, let me try it out, 13,600 divided by 6,800. Of course, it's just 2, isn't it? Because remember, the amount was twice the principal. Of course, that's just 2. So there's step 1. So we did that. Step 2, how are we going to get that T, the T that's up here, how are we going to get that thing out of the power zone? It's up here in the power zone. We can't like divide by the E 0.20 or something. That's why. You think, yeah, that might work. No. The E 0.20 is not multiplied by T, right? If it was E to the 0.20 times T and T was down on the base level, then yeah, you would just divide by the E to the 0.20 and boom, T'd be alone. But T's not down there in the base level. He's up in the power. So the E to the 0.20 is not just times the T. The 0.20 is, you might say, yeah, the 0.20 is, yeah, he is, but the E is not. The E is up in, the T is the E's power. It's not multiplied by the E. So we can't just divide to handle it. That's not going to work. We can't just divide. So what do we do? How do we get T out of power? What's the opposite of a power? ln both sides. Remember? So that's a really important lesson in this section of the course, is that powers and logs are opposites. It's hard to remember because there's not a log on the scene anywhere. So you just have to know it. You just have to know when you've got a letter up there in the power zone, you've got to log both sides. That's how you're going to get rid of it. So I'm going to do that. I'm going to go ln on this side, ln on that side. And then what will happen? Step 3, let me come on down here and go to step 3. Whoops, little mistake there. Step 3, power. So there was step 2. Power drops down to the front. So this whole power will drop down to the front. Powers drop down to the front. So this becomes ln2. That power drops down 0.20t ln1. So the power, that's the great thing. Logs and powers are opposites. They cancel each other out. That power drops out of power down to the front. And then you want to remember ln of e, what's that? That's just 1, isn't it? So this is just 1. So we just have 0.20t is ln2. Now it's easy to solve for t. You don't need me to tell you. You just divide by the 0.20. Once the t's out of power, it's a piece of cake. Then hit the buttons on your calculator. ln2 divided by 0.20. I'm getting 3.4. What is it? 3.4657 rounded to 4 places. That's how many years? About just under 3.5 years. So it'll take just under 3.5 years. That's time, right? Years. Just under 3.5 years for the money to double. That's impressive, isn't it? $6,800 will double. It'll become, what is it? $13,600. It'll double in just 3.5 years. 3.5 years, it'll double. And, of course, that's a great interest rate. I mean, 20%. Where are you going to get 20%? Even risky stocks don't usually pay 20%. So that's a super high interest rate. So, yeah, if you could get that great interest rate, then you could double your money in 3.5 years. That'd be a fabulous investment. Okay, 3.5 years to double your money. Now, that's the first part. Now, the second part of the question, they want us to do the same thing again. This time, how long will it take 680,000 to double? So we took this amount we had in the first part and we multiplied it by, what is that? 100, because we added 2 zeros. Right now there's 4 zeros. There were 2 zeros. So that's times 100, adds 2 more zeros to the back. It's 100 times as big. So 680,000. So it's how long for 680,000 to double at the same thing at 20% compounded continuously. So we use the same formula. We're going to use the PERT again. And double, what is 680,000 times 2? It's going to be a lot. It's going to be 1, 3, 6, and 4 zeros. So what is that? So 1,360,000. So that's the amount. The amount is double. P, the principal, is 680,000. So we want the amount to become 1,360,000 is P, the principal, which is 680,000. E to the R, the interest rate is 20%. T, trying to find time. So same thing as the last one, you got to solve. So first step, got to get this base to the power alone. So divide by 680,000. First step, boom. And so now we get e to the 0.20t. And guess what this is? 2. Do you see right now that on this line, we're exactly the same thing we had here? See how this is the very same equation as this? So the answer is going to be the same, which you can probably see up here. the answer is the same. So it doesn't matter. The point of this example is it doesn't matter how much money you start off with. In the end, you end up with a 2 over here because you want it to double. You want the amount of money to double. So it's going to be the same time. Any amount of money will double in 3.5 years at 20% interest compounded continuously. That's the point of this example. So I don't need to go on and solve anymore. There we go.